Hey everyone, so this is the third session of our blockchain series, and so I'm joined again by the lovely Nadisha, she's been basically bugging me to do this third video for ages, so I thought I'd make sure that we keep the momentum up. So in the second session, what we did was we talked about hash functions, right?
Yep.
And today's session is going to be about another really important aspect of the whole sort of cryptography side of blockchain, which is the public and private keys, right? So we're going to talk about that. Then we're going to talk about digital signatures. So essentially how you use public and private keys and the hashing that we talked about in the previous video to actually sign a document digitally in a way that ensures that there's integrity and it hasn't been, let's say, altered from a certain point to another point in time, if it's been sent over over the internet or whatever, right? So, and then once we've done, I'll show some examples of that to sort of clarify it. Then we'll talk about Bitcoin addresses a little bit, just kind of to give a flavor of what a Bitcoin address looks like, and then we'll look at the first ever Bitcoin transaction in the actual, remember that website, blockchain.info, just to give you a flavor. But the main emphasis is going to be about the public and private keys, just basically getting a solid understanding of how that works. Okay, so let's start with the first slide. Okay, so the first slide, we're going to talk about public-private keys, and in the context of a sort of a real-world analogy, right? So think of it like a little sort of little chest that you can. So normally a chest, you'd lock the chest with one key, and you'd unlock it with the same key. Now, I'm just going to sort of describe a sort of a fictitious example of a chest where you would have one key to lock it and the other key to unlock it. So you can't lock it and unlock it with the same key, right? And let's just call the key that we're locking the chest with the public key, and we'll call the key that we unlock it the private key. Okay. Right. So let's say I can put a sensitive document like a check or whatever. I can lock it in this box. I can lock it with the public key, right? And only the person who has the private key for that chest can unlock it. And these keys come in pairs. So when you buy one of these from the hardware store, you'll buy the chest, and the lock is configured to basically have a matching public and private key, right? And it's really as simple as that, right? So that's how it works in the real world. So if we take it to so if we go to the second slide, I want to show you how this can actually work in with an actual example with some text, right? So how we can lock it and then unlock it, right? Okay. So I've got some commands over here which I'll post down in the comments below, because it's actually quite useful to be able to play around yourself. I'm using a MacBook which has sort of a terminal window, so it's much more. These commands would only work on that, but you can actually play around with this yourself. So I'm not going to explain what the syntax of these commands are. Although if you're interested, you can just ask me and I'll explain below. But I'm just going to run some of these commands. I'm going to copy them and run them in my command window over here, right? So the first one, what I'm doing is I'm generating a corresponding public and private key. Okay. Right, on my system, and it just generates them in text files. Right. So if we look at what we just generated, I can see I've got a public key and I've got a private key. And these are just very long numbers, like huge numbers. Right. And I can actually, I can actually look at what the public key looks like, right? And it's just a huge long string of numbers, right? So that's your public key, right? And I can do the same with private key. So again, it's the same. It's the same concept, right? So what we've done there is we've generated a public key and a private key, right? Now, what we do once we've generated those numbers is we apply those numbers with a mathematical formula, which is basically called encryption, and the other input obviously is what we want to encrypt or decrypt. Yep. and out the other side of that function, we get some ciphertext, which is your encrypted sort of secret scrambled text.
Right.
Right, and then you would use so if you encrypt with the public key, you decrypt with the private key. Right. So if we just actually show you an example here. So I'm going to use just a simple sentence and show you how it can encrypt a simple sentence. Right. The cat sat on the mat. It's my favorite sentence. So what I've got now is, so I've said basically take this string, the cat sat on the mat, use this tool to generate to do the encryption, and I'm going to use the public key that I just generated, right? And then I'm going to create a cipher text file.
Yep.
So the contents of that file is the scrambled version of that, the cat sat on the mat.
Yep.
So if we have a look at what that looks like, right? It's just garbage, right? Nobody in their right mind or wrong mind, whatever, can read that, right? So we've created this cipher.txt, right? Now, what we can do is that if we can then show what happens when you decrypt that cipher.txt with the private key, right? So I'm just saying that don't worry about the syntax here, but we're saying take this file cipher.txt, okay?
Yeah.
And decrypt it, and the key you're using is private key.
Yep.
Right, and hopefully, there you go, the cat sat on the mat.
Right.
Okay, so
sorry, where is the cipher.txt file saved?
in the same directory as I'm working here.
Right. Okay.
So all the files have been created in the same directory.
Oh, I see. Right.
You want to become like a Linux guru, do you? No.
I'm not sure about that.
Okay.
Go on.
All right. So yeah, don't worry too much about the commands, but they'll all be down below. You can play around with them later. I'm sure you're looking forward to that. Right. So basically, I think you kind of get the concept of. So you have an input, and cipher.txt could be it could be any number or any digital file.
Any amount of text or picture.
Yeah. Right. So that said, and with that being clear, right? So if I didn't have the private key, there's no way I'd be able to decrypt that cipher.txt and get the original message back. So I think we can move on and talk about the next thing, which is digital signatures. So digital signatures is actually combines the public and private keys that we just talked about with the hashing that we talked about in the previous video, right? And the concept. I hope this diagram doesn't look too intimidating, but so the concept is basically take any digital document. Let's say a Word document, let's just say a Word document, right?
Okay.
And what we're going to do is we need to find a way to make sure. Let's say I need to send it to somebody over email or or whatever, and I need to make sure that the document that they receive is exactly the same one that I send, right? That nobody in between has kind of opened it up and changed some of the content, right? So, and we touched on this in the previous video that if you hash something. If you hash a document, then you get a unique fingerprint. Yeah. Right, and you can send that hash with the file, so that the person at the other end can then hash the file and compare the hash. But that doesn't stop somebody in the middle, basically just saying, well, I'm going to make my changes to the document, and then hash that, and then throw away the original hash and just send the new one, right? So what digital signatures does is a way basically to protect that hash from ever being changed as well, right? So it combines the two concepts very neatly, right? So if I want to create a digital signature for a document, and I'll show you a very detailed example again on the terminal, is first of all I'm gonna hash it, right? Okay. Then what I do is I private key encrypt the hash. So I take the hash, exactly. Right. Because there's one other thing that I didn't mention, which is a little bit of a minor detail, but just in case anybody is kind of wants to pick me up on this, with the public-private key encryption, there's a maximum message size that you can encrypt. Effectively, you cannot encrypt a larger amount of data than the actual size of your key files themselves, right?
Right.
So what you do here is you say, right, I'm going to take a hash of the document, because this document could be huge. It could be a movie,
okay.
but
Yeah.
you can't encrypt actually and decrypt a whole movie with the RSA public and private keys,
Right.
because the public and private keys limit the size of the thing that you can encrypt. But the hash, if you remember, is always 256 bits, right? It's a unique fingerprint for that file to identify it, but you can't go back to the original file from that, because obviously you've just massively reduced the amount of information, right? So we hash the document to 256 characters. If you remember, what that looks like is basically a string of 64 numbers, like A, 6, E, 1, 2, F, G, 64 characters, or 256 ones and zeros, right?
Yeah.
So that's your hash. Then, so as I said, you then encrypt that hash.
You encrypted like the cat sat on a man.
Exactly.
Like that sentence.
Exactly.
Right.
You take that message, 200, which is going to be 64 characters long.
Yeah.
You generate a public and private key, just like we did that time. You encrypt the hash with the private key. That's going to give you a kind of cipher.txt equivalent thing, right?
Right.
Then what you do is you take that encrypted hash, and that is called a signature, right? That's just terminology, but just that is basically it's called a digital signature. And what you do is you send that signature along with your original document that you want to send and the public key. Right? So you send three things together to the other end. And so when that document gets to the other end, so I've just put a squiggly line here to represent, so this is, in transit, and this is on the other side, right?
Yeah.
So the recipient of this package has three things. He has a document.
Yeah.
He has a signature, which is some scrambled ciphertext, and then he has the public key that you sent.
Right.
Right. So what this person then does to check that this document has not been changed is he or she will basically take the document, and hash it using SHA-256, same hashing function as we used here,
and compare it.
And then he takes the signature,
right,
decrypts it with the public key that he received.
Yeah, and then compare.
Exactly. So he decrypts it. He's going to get the cat sat on the mat, right? In terms of the analogy, right? He decrypts that signature back, the cipher.txt thing.
Yeah, so that's the SHA. That's what happens when the digital document went through SHA-256.
Exactly. So what comes out of this is the SHA-256 hash.
Yeah.
Right.
Yeah. And then you compare.
And then compare these two together.
Yeah.
And if they're equal,
then it's fine.
Then it's fine. So if they're equal, what it means is that this document cannot have been changed, right? Otherwise, this signature would not be valid, right?
Yep.
So because the hash would be different.
Okay. Quick question.
Yeah.
So I thought how it worked was that you would lock it with the public key, and then you would open it with a private key.
Yeah,
that's what you said before.
Yeah, but that's a great question. So basically, the way these keys work, right? The public and the private keys, right? These key pairs. You can do either, right? You don't have to lock with the private and unlock with the public.
Right.
There's nothing. So basically, So this is a special case, because you're right. Normally, it depends on the use case. So if you're more interested in keeping the contents of the file secret, then what you would do is you would lock with the public key, and then you would send that encrypted document.
So you can interchangeably use either.
Exactly.
Okay,
exactly.
Right.
And that's a great question. So this, when it comes to digital signatures, is a very special case when you're talking about public and private keys, where the usual use case kind of flipped on its head, and we said, do you know what? We're actually we're not bothered about keeping the document secret. What we care about is that we're using the private key to prove that we own that public key, and that the document which we've sent, without being any, we haven't encrypted this document when we sent it, right? It's not confidential. All we're trying to do is say, by signing this with the private key, anybody out there, because the public key can be given to anybody, right? Anybody can validate that this document has been signed correctly. So you're absolutely right. They can be used interchangeably, and normally and often, when it comes to sending confidential information, you would do that. You would basically you would send, if you wanted somebody to send you some information, you would send them your public key,
right,
and say, guys, can you please encrypt with the public key, send that encrypted data to me, and only I can decrypt it.
Yeah.
But this is basically, I know we're kind of labouring the point, but yeah, it's really important that when it comes to signing, digital signatures is basically, okay, well let's flip it on its side or upside down and say, this time we're going to encrypt with the private key, and then this validation can be done by anybody, right? So we can send this signature, digital document, and public key to anybody, and they're all welcome to check that this works. Now, the only thing I would say here is, so you might ask, okay, well, what if somebody wants to sort of seize this document in transit, right? Let's say somebody gave it to you on a USB stick and said, can you take this to Bob, please? Right? What's to stop them taking that document, opening it up, modifying it, right? Hashing it, generating their own public and private key, throwing away this one, the one that was originally sent, and just basically signing it with their own private key, right? So that obviously can happen. So what I would say would happen is, let's say you're the person here, right, who wants to send me this document, right? So this is you, right? And
I'm just wearing a skirt.
Yeah. And then you're sending me this document, and I'm here.
Yeah.
And I receive it. So first thing I would do is I would take the public key that I've been delivered and do this validation. But I would also probably give you a call and say, can you read me your public key, right? Like, can you actually so we make sure the public key that I've used is the same one that you sent, right? So does that make sense? All right. So I'm going to show you a real use case of how you would sign a copy of the complete story of Alice in Wonderland, right? So I've got Alice in Wonderland here on a big text file. Now, as I mentioned before, that file is too big just to basically encrypt it,
right,
with my private key and send it to you, to ensure that nobody's changed it. So what I do is I'm going to have to hash it, sign the hash with my private key, and then the recipient's going to validate the hash with the public key, right? So that's Alice in Wonderland, right? So we have the text file there. Now, what I'm going to do, so example 2, I'm going to check. First of all, what I'm going to do is show you. So this is the command to actually do the SHA-256 hash of a file, right? So, and as I said, it gives you, this is basically your 64 character letters and numbers of that whole big file.
Alice in Wonderland.
Yeah. So if you're ever wondering what the hash of Alice in Wonderland is, that's...
yeah, because I've spent time wondering that.
Yeah. Okay. So that's the hash. Now, what we're going to do is we're going to take that hash and we're going to sign it with our private key, right? So this command, again, we're going to run SHA-256 on Alice in Wonderland, and then we're going to encrypt it with a private key, right? So, and it's going to be stored in a file called signature. Right?
Okay.
Right. So then there's signature. We just created that. So the signature is the encrypted hash.
Right. Okay.
And we can have a look at what the signature looks like, and it's just garbage, right? So the next command, all I'm doing is I'm saying take the signature that I just generated and Alice in Wonderland the actual unencrypted full story file that I want to assign, and the public key, right? Take those 3 files, put them in basically a package, which a tar file is just like a zip file, right? So put them in a package together, just like I said in the previous slide.
Yeah.
You take those three things, put them together. Then all I've done is basically create a separate directory and copy that tar file to that directory, and then I'm unzipping that tar file in the directory, right? So I've basically created a package with those 3 things, ready to send, and then just on my local file system I've sent it there, and then I've unzipped it. So then at the other end, right? At the other end, now we're in a folder called inbox, and what I have is I have these files. So now we're on the receiving end.
Yeah.
Right. I've received this package. I've unzipped it, and now let's have a look what's inside. Right. So first of all, we can see that we have a public key. Right. And at this point, I would get back to the sender and say, okay, the public key that I've received is this. Does this match the one does this match your public key that you used to sign it? And they'll confirm, yep, that's character by character, yes, this is it.
Public key or private key?
Public key. I don't know the sender's private key.
All right.
Right? Yeah. But the sender sends their private key. Sorry, their public key. The sender sends their public key. So in order to verify the signature.
Yeah.
But to ensure that nobody else in the middle has said, well, throw away your public key, screw that. I'm gonna basically edit this document myself and use my own private and public key. Use my own private key to sign it, and then send my own public key to the.
So, do you have to confirm it?
You don't have to.
I don't have to.
But if you don't, then you don't know whether somebody in the middle, let's say somebody in transit, let's say as I mentioned before, if you basically put that file on a USB key or that zip file and said to Bob, can you please take this USB key and give it to Jean, right? Because Jean wants this document. So what stops Bob stopping halfway along, opening up that zip file, right? Making some changes to the document, generating his own public and private key, right? Throwing away the hash, so throwing away the signature, and the public key that Bob gave him, generating it himself using his own private key. And putting that new signature and his own public key back in the package, and then delivering that to Jean, right? And then the whole thing is a bit pointless, right?
Yeah.
So this is why the recipient would call the trusted sender and say, okay, I've just received a package. Okay, it's this document. I've got a signature here with a public key of this. Can you confirm this is the correct public key, right? That ensures that nobody in the middle has re-signed it with their own private key. Yeah. So what we would do, so we would check that it tallies with the sender's public key, and then all we do is we decrypt. I'm just going to do that again. Decrypt. So we're gonna take the signature that we've received.
Yeah.
And we're gonna decrypt it with the public key that we've received, which we've just validated with the sender, saying, yeah, this checks out. This is the right public key.
Right.
Right. So now what we've got is the original hash.
Ah.
Right. So remember when we first checked the hash for the Alice in Wonderland TXT, right? This was the exact number. If you remember, it was D9DB7, right? Take my word for it.
I'll take your word for it.
Right. So basically, I've missed one final step. I also have to check the hash myself. Right? The recipient has to check the hash themselves. Right. So
okay.
Yeah. So this is the file that I received. Right.
Right.
Alice in Wonderland.txt.
Oh, you have to compare it.
Right, yeah. I have to compare it. Yeah. So I compare. I hash it, and then if somebody had modified that file in transit, I would have got a different hash.
Yeah.
Right.
Yeah.
And also the signature I've just validated using a public key that I've confirmed with you, the sender, is the correct public key. So in that sense, we've made sure that document was signed by you and only you, and it hasn't been modified since that time. So that, okay, we've talked around it a lot, but that's a really, really important concept in Bitcoin, right? It kind of underpins the whole, or one of the things that underpins the whole thing, right? Okay. So hopefully that's clear. Now go back to this. So I'm just going to give you a quick kind of like a taster of what a Bitcoin address looks like, because it's kind of very related to the public and private key concept. And I'm not going to go into too much detail here. It's just to kind of introduce the theme, right? Yeah. So if we think about it, we've been talking about a public and a private key pair, and I normally use like a red to represent a private key and a green to represent a public key. Public key is a piece of, in the computer world, it's something that can be freely distributed with anybody and with no consequences, okay. Right? So with Bitcoin addresses, essentially, what a Bitcoin address is, it's ownership of a public and private key, and that is basically all it is, right? Right. So now, when you talk about a Bitcoin address that you pay to, so for example, if I want to pay you some Bitcoins, right? The way that happens, we won't go into too much detail here, we'll go much deeper in next videos, but you will tell me, okay, this is my Bitcoin address. It's like a bit like my PayPal address or whatever, but it's a unique address. Yeah. And again, it's a long series of numbers, and it looks very much like the hash that we saw. Yeah. And if I want to pay you Bitcoins, all I do is I basically say, right, I pay this number of Bitcoins to this address, right? Okay. So that part of your address is effectively, it's a hash of your public key, right? So if you start if you have a Bitcoin address, meaning if you want to start paying or receiving Bitcoins, you have to generate a public and private key pair, right? You don't have to do it manually. There are various applications out there that that manage the whole thing. But effectively what happens is you generate a public and private key pair. Mm-hmm. The public key goes through a couple of different hash functions to basically format it in a way that is sort of aligns with certain standards with Bitcoin. But the point is that it's derived from the public key, and that's because it's public, that's your Bitcoin address, and you can distribute that to anybody and say, okay, if you want to pay me Bitcoin, you have to reference this address, right? Mm-hmm. The private key is only ever known by you. Mm. It's so the software that generates your Bitcoin address will keep that private key locally on the system. It should never, we can talk about in a later video about how you actually manage your addresses. Sometimes people write them down on pieces of paper and lock them up in a safe. We'll get more to that in later videos, right? But that ultimately is a Bitcoin address. It's a private and public key. The public key is hashed through a couple of hashing algorithms and becomes a publicly facing Bitcoin address. And I'm just going to show you a second on the blockchain.info site. Yeah. And then to guard the private key with your life, because if the point about Bitcoin is that if anybody has the private key corresponding to this Bitcoin address, they can actually spend any Bitcoins that have been sent to that address, just like you. So your ownership of the Bitcoins that have been sent to that address is only represented by the fact that you know the private key that corresponds to that address, right? It's not like those Bitcoins are in your name or anything like that, which is why you have to make sure that you keep the private key secret, right? But we'll go into more detail on that later. So a Bitcoin wallet, I just want to, it's another sort of quite interesting concept, is basically typically, let's say on your iPhone, right, it's just an app, right? And that app on the iPhone is capable of generating these public-private keys, right? Generates them for you. It stores them inside the app, and you can generate many different pairs of these. In fact, it's recommended that you sort of frequently recycle them and change your Bitcoin address from time to time, right? So a Bitcoin wallet is basically, think of it as a piece of software that stores all these public and private keys together, and that's really that. So in the next video as well, we're gonna talk a bit about a really cool app for iOS, which is a Bitcoin wallet, and it's called Bread Wallet, right? So we're going to install it on your phone, and then I'll actually pay you some Bitcoins.
Yay.
And we'll also go to a Bitcoin ATM and show you how to withdraw some Bitcoins and actually get them in your wallet. So that when you actually start playing around with it, you really kind of understand better how it really all works, right? So, but Bread Wallet, if you guys are looking for a way to get started with playing around with Bitcoin on iOS, on your iPhone, I would definitely recommend Bread Wallet. Okay, so that's, but do you understand, do you kind of get a vague idea that a Bitcoin address is just basically a private key and a public key?
Yeah.
Right? Simple as that. So just thought I'd quickly show you just going back to reinforce the thing about the blockchain info, just so we keep that kind of fresh, and show you the first ever Bitcoin transaction.
Yeah.
Okay, so remember this site, right? This is the blockchain.info, and so you've got your blockchain blocks, right? And now, since the last video, obviously lots more blocks have been added to the stack, so now we're on 418,940 blocks.
What was it the time for?
I don't remember. And you see, look at this. This is quite interesting. This block only had 39 Bitcoin transactions in it, whereas this one had 1,520. So, and these are the transactions that are coming through. These Bitcoin transactions. These are the things which are basically getting stored in the blocks, right? So.
And what kind of information is this? People buying things in Bitcoin.
Yeah, exactly. So
now
each of these line items is a live feed of Bitcoin transactions coming through. And when I install Bread Wallet on your thing for the next video and transfer you some Bitcoins, what we'll do is we'll actually see that transaction come through, and then we'll watch and wait and see it actually be confirmed in a block, right? So that actually really helps, because you're like, oh, that's my transaction, and that's the block it's in, and you know that's going to be in the blockchain forever, right? So what I want to do in this one is just to have a look at the first ever block. So this is block 0, which is the first block in the blockchain, right? So I just wanted to show you this quickly. If you remember the guy with the box of checks, right?
Yeah.
The one which had no parent, and we see it has one transaction. So the contents of a block in the Bitcoin blockchain are Bitcoin transactions, and you can see there's only one transaction in the first block, and we can see, so you can browse and open the home page for that transaction, and basically, we're going to get into more details in future videos about exactly what these inputs and outputs and what the kind of anatomy of a transaction is. But just because we were talking about Bitcoin addresses, right? Just to show you, for example, what a live Bitcoin address, right? So that what we're saying is the first ever Bitcoin transaction ever was paid to this Bitcoin address, right?
Okay.
And that Bitcoin address was derived from hashing the public key, right, of a public-private key pair that was basically belonging to the original recipient of the first ever Bitcoin transaction. And everything since then has evolved from there. But that's what a Bitcoin address looks like. I just want to give you that kind of and so each address on this site you can click and see all the transactions that they've ever been involved in, right? So I don't want to sort of go into too much detail there, but it's just to kind of give you a flavor, and also just to kind of keep you familiar with the blockchain concept, because we kind of diverted and talked about private keys and stuff. Also interesting, the first ever Bitcoin transaction has a little so each Bitcoin transaction or a special type of Bitcoin transaction we'll talk about has a little space for the Bitcoin miners to insert like a random freeform piece of text, right? And so
and why is that?
It's it's actually used nowadays to help them find to solve the hash problem, right? So they play around with different combinations of characters and stuff. And
Okay.
so it's used for that. I don't want to. We'll cover that like a lot in subsequent videos. Okay, but you see the message. The Times, 3rd January 2009. Chancellor on the brink of second bailout for banks. So this is kind of in the kind of Bitcoin folklore, if you like, that the whole part of the reason why people wanted to come up with Bitcoin was a sort of a better way. This is more the kind of economics side and the kind of digital currency anarchists side of things will say, oh, these evil banks with their fiat currencies and their bailouts and stuff, let's find a better way using Bitcoin. So, but it's quite interesting that, this in the first ever Bitcoin transaction, as part of the transaction, you've got this text, right? And again, this is like buried right at the bottom of the blockchain. So that's there for all time. So you'll always be able to go back and identify this transaction like that.
Yeah.
Right? Okay, so in the next slide, Nadisha buys Bitcoins from an ATM, right? So I'm going to take you to the Bitcoin ATM. We're going to get Bread Wallet installed on your phone. I'm going to transfer you some Bitcoins, and maybe we can we'll buy something in Bitcoin as well. I think there are some trendy soup kitchens in Shoreditch where you can.
Let's go for dinner.
Perfect. All right. So hopefully, guys, you found that useful. Any questions, any comments, as usual, please put them down below, and we'll see you in the next one. Bye.
Bye.